Hello everyone. So in this video we will see the demonstration of the algorithm that how we can find the maximum value in a binary tree. So in our previous video we saw the demonstration of the algorithm step by step. So in this video we'll simply code the algorithm and see it's working. So here you can see in our previous videos we created one class as binary tree which had a root as an instance variable of type tree node. So this is the class of tree node which we created in our previous videos, and we saw different algorithms. So here let's say we are given this binary tree and let's say we provide a maximum value in this binary tree as 8 and rest of the value we keep as it is. Now we want to write an algorithm where we can find the maximum value of this binary tree. So friends, here in case if you find any difficulty, you can watch my previous videos where we have demonstrated each and every line of this code step by step, and we have demonstrated all these algorithms step by step. So let's code the algorithm to find the maximum value of a binary tree. So here we have created one method at findMax whose return type is integer, because we want to return the maximum value of a binary tree. So here we'll simply return findMax. We'll pass in the root because we need to pass a root to find the maximum value of a particular binary tree, which we also saw in our previous video. So here we'll create a method as public whose return type will be integer findMax. And this is the method which will take the root of the binary tree and will simply return the maximum value of this binary tree. So here this is our binary tree whose maximum value is 8. So let's see the code to find the maximum value of this binary tree. So as we discussed in our previous video that this algorithm is recursive in nature, the first thing we provide is the base case. We simply check whether root is equal to null or not. So if root is equal to null, we'll simply return the minimum value, because as root is null, it simply signifies that we can simply return the minimum value of the integer. So here we need to find the maximum value of this binary tree, and if root is coming out as null, then we need to return an integer value. So we can safely return the minimum value of the integer, because beyond that there won't be any minimum value, and our task is to find the maximum value. So this minimum value won't affect the maximum value of this binary tree. So after providing this if check for the base case, the first step is to store the root's value. So we are creating an integer value result and we are storing the root's value into this result. And also we discussed the basic idea behind this algorithm is, in order to find the maximum value of a binary tree, we simply compare the root's value to the maximum value of its left subtree, and also we'll compare this value with the maximum value of its right subtree. So when we compare these three values, we come to know what's the maximum value of a binary tree. So this algorithm is very recursive in nature, and this is applied on each and every node of the binary tree. So where we simply store the root's value, then we go to its left subtree to find the maximum value of the left subtree. Once we get that value, then we go to its right subtree and we find the maximum value of the right subtree. And after we get these three values, we compare them with each other and we get the maximum value of the complete binary tree. So here, after getting the root's value, we simply try to get the maximum value of the left subtree by calling the findMax method recursively, providing root's left value. So here we are simply providing the root's left, which is the left subtree of this root. and whatever the value this findMax method will return will simply store in the left variable. And similarly we do it for the right subtree. We call findMax recursively, providing root's right value. So in order to see how this recursive nature works, you can watch my previous tutorial where we demonstrated this recursive nature with an animation. So you can watch that. And here, after finding all these three values, we'll simply compare it with each other. So the first step will compare whether left value is greater than result or not. So if left is greater than result, we simply update the result with the left, because at the last we need to send the result, and which should be the maximum value. So first we are comparing left with result, and then we are comparing right with result. So if the value of right is greater than result, we are simply updating the value of right to result, and at the last we are simply returning result. So here you can see that we are comparing all these three values here. If left is greater than result, we are storing the greater value in the result, and then we are again comparing whether right is greater than result or not. And if right is greater than result, then we are storing the value of right into result, and finally we are returning result, because this will be the maximum value among these three values. So here you can see this is the algorithm to find the maximum value of a binary tree. So let's test its working in the main method. So first we are creating this binary tree with these values, where we know that 8 is the maximum value. And here we are simply printing the maximum value by calling the findMax method, which internally will call this findMax method, providing in the root, which is this root, and this root is being created here with this create binary tree method. So after we create this binary tree with this hard-coded values, and when we will call the findMax method, we will get the maximum value of this binary tree. So here you can see it printed 8, because 8 was the maximum value of this binary tree. Now let's say if I update any value to 10, and if I run the code again, you can see answer came as 10, because 10 is the maximum value of this binary tree. So friends, here we saw the algorithm to find the maximum value of any binary tree, which was basically recursive in nature, where we compared the three values. One was the root value. We compared it with the maximum value of its left subtree, and we compared it with the maximum value of its right subtree here. And finally we returned the result, which was the maximum value of the complete binary tree. And this algorithm we applied on each and every node of the binary tree, because this is recursive in nature. And in order to see the complete animation of this recursive nature, you can watch my previous video. So friends, this was all about this video. I hope you have liked this video, and in case you have liked this video, then please like, comment, share and subscribe my channel. Thanks, have a nice day.